How do we prove something in mathematics? For instance, how can we prove that the square of an odd number is always odd? Well, you might initially try a few numbers. Oh, 3 squared equals 9, and 5 squared is 25. Okay, so it makes sense. But what we're really trying to do is prove that it's always true for any odd number. There are infinite odd numbers, and you'll never be able to try them all. So how do we do it? Well, this is the fun part. Stay tuned, this will be our final proof in this video. Proof is definitely not something you'll master in a few minutes, but in this video we will give you a starting point for understanding mathematical proof. We start with the simplest form of proof, direct proof, where we prove that a statement is true using maths that we know is true. Most of the time, we're using algebra, since algebra is the language of maths. But this is where it can also get a little bit tricky, because you might ask, what can or can't I use? Well, the best way to learn is to do. Let's prove 3 statements using direct proof, with each one getting a little bit harder. Statement 1. Let's prove that the sum of an even number and an odd number is always odd. Let's start by defining our odd and even numbers algebraically. So an even number can be written as 2 multiplied by any integer. We'll use m, but you can use any variable you want. An odd number can be written as 2 multiplied by any integer plus 1 or minus 1. We'll use plus here. We'll also use n for our odd number. Now it's very important to state that m and n are integers. We also need to use 2 different variables, because if we just use one variable, the 2 numbers would just be consecutive. And even though one is even and one is odd, we haven't truly proven our statement. The use of 2 variables lets us prove that no matter how big or small these 2 integers are, the result will always be odd. Now that we've defined our 2 numbers, let's take their sum. A plus b equals 2m plus 2n plus 1. How do we now show that this is always odd? We factorize 2 from the first 2 terms. Now since m is an integer and n is an integer, m plus n will be an integer. You don't need to prove this bit because it's mathematically accepted as fact. So for clarity, we like to write this as 2k plus 1. Now since this is in the form of an odd number, 2 multiplied by an integer plus 1, we have proved our statement. Let's move on. Now we'll prove that if a and b are positive integers, where a is divisible by 5 and b is divisible by 3, then ab is divisible by 15. To prove the statement, let's start by defining a and b again. A is divisible by 5, so we can write a as 5 multiplied by some integer. B is divisible by 3, so we can write b as 3 multiplied by some other integer. We also need to define our variables as positive integers, just like before. Then AB equals 15mn, which can be written as 15k, where k is an integer, since mn is an integer. You're multiplying 2 integers, and that will always be an integer. Again, you don't need to prove this. Therefore, AB is divisible by 15. Let's do the final proof. Statement 3. Prove that the square of an odd number is always odd. First, let's define our odd number. We'll call it 2n plus 1, where n is an integer. Then, if we square it, 2n plus 1 all squared gives us, after expanding, 4n squared plus 4n plus 1. We're trying to show that it's odd, so let's factorize a 2, giving us 2 outside of 2n squared plus 2n plus 1. This can be written as 2k plus 1, since 2n squared plus 2n will be an integer if n is an integer. Just think about squaring, multiplying, and adding integers. The result will still be an integer. Therefore, if we square an odd number, it is always odd. That's it. We've proved 3 statements. Your turn. Have a go using what you've learned. Prove these statements. Proof can be a lot of fun, and it also really deepens your understanding of mathematics. If you found this helpful, feel free to like and subscribe for much more. That's it for this video. As always, thanks for watching. See you next time.